I'm Will, BridgeWorksGames.com. This is my buddy Luke, and we are working on our tank shooter game. What did we call it, Luke?
Tiger King.
I love it. So hit play. Where were we when we left off?
I'm with the times. What am I doing? I'm hitting play.
Yeah. See what you got.
Think I can drive around.
All right, and then you hit the space bar, and how is it jumping?
It's not jumping.
Let's work on jumping. I think it'd be a good spot to work on. So our dude here, our tank, right now we clicked on plane. You can see that in the hierarchy. We'd want to click on tank, and then we'll be able to see the script there. And if you double click, it's really hard to explain, but yeah, it's that dark spot right there. You double click that, it'll load up Visual Studio Code. So what I want to do is kind of zoom into this and look at what this code is doing. And I think one of the best ways to do that is that's really zoomed in.
Oh, is that not what you meant?
It's not exactly what I meant. What we'll do is one of the best ways to comment code is to put the bodies of code into functions and have the function names tell you what's going on. So let's do that. So lines 22, what's line 22 doing? And that's probably, like you had pointed out earlier, it's probably what our, that is maybe what the problem is, but let's break it up into functions first, and that'll kind of make our code a little bit more modular. So what do we do? Grounded equals controller.isGrounded. So what is grounded player? And we talked about it earlier, it was a Boolean.
It's a Boolean.
Yeah. And then what's controller?
That's the thing we got made here.
Yeah, the character controller. It does a lot of like the collisions and the physics. Yeah, it handles all that. And then isGrounded is a function within that character controller. Let's look at that real quick. Let's look at the Unity documentation and take a gander at that. So yeah, if you want to open up your browser for me. And then, actually, yeah, maybe. You might want to type in character controller. Oh, actually, look at that. Hot dog.
I'm the master of Google food.
You are. So what's this one say? Was the character controller touching the ground during the last move? Yes or no? So
Wait,
cool.
what's the ground? How do we know what the ground is?
That's a deep question in life. How do we ever know if we're grounded or not? I think that the plane that it probably just looks for collision from the plane that we had. We remember we created a plane that had a collision box around it.
I thought it didn't, and that might be our problem.
Otherwise, if it didn't, our little tank would just would fall right through. So Mesh Collider is the fourth component that's installed. Otherwise, I love the pushback. Challenges me. It's good. But what I wanted to show you is that if you click on the words character controller on the left column, whoa, you're fast. We'll be able to see more. And from here, these are all of the different variables and functions that we can call from it. So isGrounded is there in the middle, but there's also, we can adjust the center. We can adjust the skin width and all that. And I don't want to get into the details of all of those. There's no need for what we're doing. But that's what isGrounded is supposed to do. So let's separate our code into functions back in Visual Studio Code. So right now, what is this one doing? If grounded player and player velocity.y is less than 0. What is player velocity.y?
Like up and down speed?
Yeah, actually, so double click on player velocity and then we'll see where it comes in. And there it is. It's just a vector 3. So vector 3 would be 3 arrows pointing, and you've got your Y component, and then you've got your Z component, and then your X component. It's left to right. So it has that, and right now it has the player velocity.y. So that would be up and down. And it's just a vector 3. It has nothing to do with velocity. It's just called that.
So it's just direction.
Yeah, that's all it really is. And where does it get used? So if you double click on player velocity again, we comb through. Where's the next instance of it? It gets set to 0 there in the body. And then what's it do? That one gets set for the jump function. And then if we keep going on line 42, it takes its gravity value and then multiplies it by delta time. But here's the part that I want to see. It's on line 43. Like you just said, it's the direction. All in all, that's what it turns out to be. And we do controller.move. I'm pretty sure if we don't have to, but if we went back to our documentation in Unity, we would see .move as a function available for the character controller. But it just takes the vector and it multiplies it by a scalar, which is our time.delta time.
Okay.
So yeah, you're right. It's the direction. That's really all it is. Cool. Let's make some of this stuff public. Let's look at it in the inspector, and then we'll get a better idea of what's going on. So I say let's make vector 3, the player velocity public, and then let's do the grounded player. Let's make that one public as well.
The what?
Grounded player, line 9, please.
Okay.
Cool, and then we'll save it, and then we'll head back to Unity. And now the biggest difference is that if we click tank, we can see our 2 variables there. While before we couldn't see them, but now they're there. So yeah, we'll hit play, and they're there now just because we declared them as public as opposed to private.
It's freaking out on the
grounded. Oh, and they're grounded. Interesting. I didn't even see that. Yeah, there it is. It flickers on and it goes off. Flickers on and goes off. So if you just so happen to be pressing the jump button precisely at the right moment, then maybe it might jump. Yeah, I see. So that's why it's all wigging out. I don't know what it's doing. I don't have the ability to edit .move in character controller. So let's create our own. Let's do it from scratch. But here's one thing I want to do. If you jump, I want to keep our focus on player velocity.y and see what happens when you jump.
It goes up.
And then it goes down. Here, I'll show you. Drive off the cliff, and we'll see what the player velocity does.
Well, yeah, that would make it go down.
Yeah, there it is. So it's always going down, and it progressively gets more and more and more, or less and less negative, or more negative?
More negative.
Yeah. So now if we head back to the code, we get a better idea of what's going on. So we were focusing on lines 22 and then 23. So 23 is, are we grounded, and is the player velocity.y less than 0? When is it less than 0?
20. When it's falling.
Yeah, when he's falling.
Yeah,
you got it. So if he's falling and he's grounded, all that body is there, that body text, line 23 through 25 or 26 is the initial landing on the ground. So we've got that. Before we start popping into functions, let's figure out what the rest of it's doing. To line 28, vector3.move equals new vector3, get axis, horizontal, vertical. That's cool. There's really no way to improve that movement. And then controller.move. It's just like our other controller.move, but this one seems to be focusing on the Z and X. So that part I feel really comfortable with. I would say let's take lines 31 through 34. It looks like it just stops it makes our player go. Game object transform.forward equals move.
Okay,
it just applies it into the player to where it's taking the direction, the forward direction, and changing that.
Yeah.
So let's take lines 28 through 34, and we're going to cut it out, and we're going to paste it into a new function called, what do you think, move or movement? Yeah, so we'll go down to the very bottom, and we're going to start a new function. And
is that out here?
Yeah, you got it. Yep. And then we're going to we're going to say void and then movement. It'd be fine. And then, yeah, there you go. You got it. And we'll paste our text in there. Perfect.
I guess I'll follow their syntax with the brackets.
And
I
then
agree with it.
now we have it though. It won't run because we haven't called it. So there's
So we gotta put in. Right?
Yeah, you got it. Sort of. What do you think? Yeah. I know you love your caps. Although I'm not too sure. They had theirs a little bit earlier. They had theirs around line 27. I don't know if we need to bother with having it in the precise location that theirs was. I say let's do it just in case.
Yeah, sure. I get you.
Cool.
I agree.
All right, cool.
Make a jump function and put this in there.
I think that's a fantastic idea. And actually, I'm wondering if we should take the other stuff from line 23 also and put it in there. I love it.
What? You were saying put this in there too?
Yeah. Yeah, I know it changed the order of our situation here, but let's just see if it gives us a problem. If it does, then we can always Control Z and go back.
Okay. So where would you like Jumpman, Almighty Overlord?
Wherever you... it doesn't matter at this point since we're all mixed up. Let's just toss it in there, see what happens. Cool. So now Jumpman is called and movement is called. And so it's kind of like Jumpman is almost like a go-to. Like it's saying at line 22 is when it calls Jumpman, it's pretty much exactly how we had it before, where the code, we cut it out and pasted it down below. That's what the code's going to be doing when we compile it. It's just...
Except it's... Yeah, okay.
Oh, no, go ahead. What were you thinking?
Well, just that we combined two parts of it.
Yeah, you're right. You know, if we wanted to get a little bit more precise, part of that code is with jumping and the other one's with gravity because it's actually pulling the unit down. But let's just save it. Let's see what happens. It's going to be hard to test since our jump kind of sucks anyways.
Mm-hmm.
But we can give it a shot. See if we notice anything different.
This is working just fine.
Cool.
I'm mashing the space bar. Let me...
So yeah, let's create our own jump.
Yeah, because the grounded player isn't even turning on at all anymore.
Are you ready to do a landing function? So landing is going to be our new function, and we're going to... I say let's call it in our update, and we'll do it first. So after... Or there, that's fine, I guess, whatever. But the idea is that if you detect if you've landed or not, then it'll have a more precise jumping. So this one we're actually not going to make a void. I mean, we could. Yeah, let's just stick with voids. That's fine.
What does void mean?
Void just means it doesn't return anything. So a function is like a... I've heard the description of an engine.
Oh.
And so we could return a true false if we wanted to instead.
How would we pass at the jump man?
Yeah,
we would, right?
We got a couple options. We can put it in our variables between lines 7 through 12. We can add that in there and make a new landed variable, our Boolean, if we wanted to.
That would make it a global scope within this class.
Yeah, we actually...
so that we could pass it around.
You got it. That's it. And we actually have one right now. It's called grounded player. So
yeah.
We could use that if you want to do that. So if you could just say grounded...
So are we getting rid of this then?
We're going to use it in a different way. So I wouldn't say we're going to quite get rid of that yet.
But isn't it going into this function then instead, or?
So what we're going to do is go to the update function, and where it says landing, and before the word landing starts, say grounded player equals. Cool. And then now if we go to the landing function where we write it, instead of void, make it a bool.
Make it what?
A Boolean. B-O-O-L. Bool. Yeah, there you go. Cool. So now what we can do is we can figure out what we're going to return. So we can cut out line 42, where it's using grounded player. It's getting updated through the character controller. We'll just cut that out.
Okay.
And then now in landing, let's use something way more intelligent. We're going to use a RayCast. It's going to be a lot more accurate for us.
Lasers.
Yes. Yeah. A lot of RayCasts are used in first-person shooters. Weapons have RayCasts that pop out, and it detects if things have been hit. So we're going to use that.
Mostly me.
Right, the lasers are focused on.
I get hits.
I don't know why I'm at. Yeah, the lasers.
I get hit a lot.
Yeah. Yeah, I know you do. You also get hit on a lot.
No, not as much.
All right. Cool. Let's hop over to Unity's documentation and look for RayCast. See what we get from them.
Okay.
Honestly, don't even know if it's going to be good, but we'll find out. So we want that fourth one, Physics.RayCast. How about that? Let's scroll down and see what the function looks like. See if I like it or not. Return. And then capital P Physics. Dot capital R RayCast. And then now we need our current position. So the best way to do that is to say this dot transform dot position. So we need to open up a brace because we're creating a function. RayCast is a method, and we're going to be putting arguments into that method. All right, so the first one is this dot transform dot position is the first argument. It's where does this RayCast start from? And then comma, okay. We're going to do, this is going to be kind of a pain because we need to go up and then down again because we're starting at the feet of this thing. So we're going to create a new vector 3 actually just above this. So we're going to, let's go line 59, hit enter. So we can create a new vector above. Yeah, there you go. So we'll write in vector 3 with a capital V. You can hit enter there. I think it'll auto correct. Yeah, there you go. And then call it downward. Downward equals, we'll say this dot transform. But now we're going to call a method. If you hit period and do capital T, this is called transform direction with a capital D for direction. There you go. Cool. And then open and close parens. And inside we're going to do vector 3 dot up. We'll put the semicolon, but we need to change our variable from downward to upward. Sorry, that doesn't make any sense.
I was going to say,
yeah,
something's wrong.
I'm just a cluster right now.
That's okay.
Cool. So now we've got, what this does is it says upward from the player's perspective and the player's direction. So just in case if it moves around, it's where the player's perspective of upwards is always going to be, not so much what it's going to be in the global space. So if we were just to say vector 3 dot up, no matter how our player's tilted, vector 3 dot up is always vector 3 dot up. But if we have our player tilted a little bit, then vector 3 dot upwards will adjust with the player. For our game, it's probably not a big deal, but I think getting the practice of using transform direction is a good habit to get into.
Okay.
So we're starting at the player. We're going vector 3 dot up is where we're going to end up. Let's subtract 1 comma. There you go. And do plus upward. There you go. Cool. And then hit a comma again. And now we're going to need a variable, a float. So call it ground length, I guess. And we'll have to declare it above.
Would that be up here?
Yeah. And then we're going to take, so we'll do lines. Yeah, that's perfect. We'll go back to where we were, and we're actually going to go vector 3 dot down. So times your like shift 8 and then vector 3 dot down.
Asterisk.
Asterisk, that's right. Your splat. And then we'll do a, we're actually not going to close it up quite yet. We're going to do one more, and this one's a what is ground. It's called a layer mask.
Okay.
So if you type in what is ground, I think it'd be fine. Yeah, perfect. Cool.
What is ground?
And then you can close it up with a semicolon at the end. So what I'm going to do here is... Yeah, that's annoying. But what I want to do is make sure that we use the same process here. And I want to make sure that we can see it. So then if you go past line 65, we're going to try to see it. And the way we're going to do that is... Actually, I want to go outside of the brace. We're going to do a new function. So we'll call this one void onDrawGizmos. And since we're using a function, we're going to have to do a capital O. I think we have to. Let's find out, actually. If you wouldn't mind cracking open your browser again, and we'll look at, if you just Google that, onDrawGizmos, Unity. Hey, look at that.
Capital O.
Well, yeah, but if you click on it for me.
Fine.
Always referring back to the document. So we can actually copy that, which is fine. Just for, yeah, the body of the function. That's perfect. So this one's going to draw a sphere. We don't necessarily want a sphere. So just change the word sphere in DrawSphere to DrawRay. And that'll work out just fine for us. Cool.
Okay.
Cool. So we got to have the same, yeah, blue's perfect. We got to have the same vector that we're using in lines 62 and 64. So we're going to have to kind of copy that and then paste it into line 69. So here's how we're going to do it. First off, let's just grab line 62 and we're going to literally copy and paste that into line 69. Yeah, that's perfect. So we're doing transform position, and in line 72, so transform position is perfect. We'll do plus upward. There you go. Yeah, just like we have over in the other one.
And then we'll take.
You got it.
This.
Yep, that's it.
Put it here.
Yeah, you got it. So now we should be able to see our little arrow where it's going.
Okay.
And we'll hit save and hop over to Unity.
Clicking on.
All right. What is ground? So we haven't declared our layer mask yet. So let's do that. Let's go back into Visual Studio Code. We'll go way up to the top where we declare our variables. And we'll, yeah, so actually we're going to do capital L layer mask. Oh, that's fine. It can, oh, we do need it to be public, excuse me. So we do need to make this one public and then capital L layer mask. And then we can call it what is ground. And I'll show you what that does. So we'll hit save.
Okie dokie.
I do like having a layer mask. We technically didn't need one. And as we scale our game up, this is going to be a lot easier to use. So what layer mask does is it says what layers do you want to have be detected as ground. For instance, if this raycast was to detect a cloud, if you're jumping in the sky, we don't want that to be ground. We want to go through the cloud. So we need to make the plane ground, and then we set our what is ground to that. So we go to plane and go up to the very tippy top right where it says layer default. We click on that. We're going to add a layer. And then on layer 6, you can say ground. And then we're going to click back on our tank in the hierarchy. There you go. And then that one we can set to ground, but we still hadn't set our plane yet. So click on plane and then make sure that's ground also. Perfect. Okay. So now the layer mask is looking for ground. We've told the plane that it is ground. So that's solid. Now we need to edit our ground length, although I don't see it. where's our ground length in there? So we might have declared it as private, or we probably didn't declare it what its scope should be. So let's change ground length to public float. Yeah, perfect.
Do you want to set it, or?
We can. We're probably going to set it in the editor. We'll probably say a little bit more than 1, maybe like 1.2, something like that.
Very specific.
Yeah.
I like it. I like it.
Let me just do a small drawing and show you why. So ground length automatically set itself to 0. I'm not too sure why, but we can edit that and make it 1.2, and that'll do what we need. Explain what the heck is going on. Can you see my screen?
Yes, sir.
All right, cool. So you've got your tank here with the awesome tank wheels and a turret and a little best drawing of a tank you've ever seen, right?
Pretty good.
Thanks. So inside of him, he's got this green capsule.
His egg.
Mm-hmm. Yeah, the character controller egg.
Yeah.
And that one goes here, and then it goes like this, which is cool. And we, in the way that the model was set, it declared this point, wrong color, it declared this point right here as, this point is 0, 0, 0. Okay. It's not here in the center.
Is that what our transform direction, or the transform position?
You got it.
Transform position, that's where that is?
You got it. Transform dot position is exactly right there. It's beautiful. And now what we're doing is we said transform position, and then we said from its perspective go up. Vector3 dot up. Mm-hmm. So that would put us 1 unit. Vector3 dot up looks like this. Vector is the same thing as saying this. 0, 1, 0. So it takes from this point and goes up 1. And that's it.
Where does it get the 1 from? Is that just the up?
Yeah. So you have 2 different ways. If you did vector3 dot up, and if you did...
Oh, because we just multiply up by a number if we wanted something other than 1.
You got it. Yeah.
Okay.
Or you could say vector3 equals
y
new vector 3 0 1 0. These are equivalent statements. And if you were to look it up, you could Google vector3.up and see you've got a lot of other options. You've got vector3.down, vector3 forward, vector3 back. There's a lot of options, but the whole point is that it just looks nicer. And you're precisely right. We're not going to do that here, but we're going to do it on the way back. So our starting point is here. We told our RayCast, we said we want to start at transform position plus 1 up. And then we want to shoot that laser right back down again. So
it's down times ground length. So we're going down 1.2 technically. Right?
Yeah, you got it. And what does vector3.up looks exactly like vector3.down looks exactly like vector3.up.
Just 0, negative 1, 0.
Yep, you got it. That's it. So it's going to shoot down, and we made this RayCast at 1.2 F for declaring a float. Good job on doing that. And the whole point is that if you were to take this little spot here, let's take our friend, and we're going to make him really big. Super big. If we were to zoom in here, and we want to have we didn't do any of this hypothetically. We cut this out. We cut this part out. And we just say we start at vector 0, 0, 0. And even though the ground is going to be exactly at that spot too, we're going to try to make this funky laser that starts from here, but kind of goes to here, which is kind of like a length of 0.01 something, and to try to detect the ground. And it's not going to look very good, or it could be, realistically, it would be 0.2. And it makes for these tiny little mini RayCasts, and they don't function as well. You kind of want to make it a little bit more than 1 unit, and that's what we're doing here. That's why we go up and then back down again.
Okay.
What do you think?
Cool.
All right.
Got it. Think. Why? Why? Sorry. Why? Why does the? Why do the shorter raycast not work? Is there something janky about it? Or?
Yeah.
Okay.
Yep. Jankified, jankaliciousness. When I was doing my my match 3 game, and it was a dynamic match 3 game where the board was constantly checking every coordinate to see if there was 3. I did little raycasts, and they had to be 1 in length. I found out it was extremely inefficient and changed it to a different system, but minus that, they had to be at least 1, and if they weren't, then detections were off or they weren't detecting at all.
Okay.
So let's look at our Unity. Let's see if our little laser is doing what we want it to do. Let's see if our math is good.
Yeah, it looks like a stubby little boy going up into the center.
That's what they used to call me in high school.
Yeah, me too.
Let's switch it to 2D. Do you know how to do that?
This button, right?
Yeah, there you go. And just for the sake of perspective, so we know that the ground is underneath the feet, and we can tell that little laser's going up and then it's shooting back down again. And that's what we want.
Okay.
So now we've got our grounded player. It's public. We have our player velocity. It's public as well. We should be able to test this out and see if our jump is working a little bit more. It's working better.
Okay. It looks like it's grounded. Uh-oh. It looks like it's still grounded.
That would make for a cool game.
To infinity and beyond.
That's my line.
It's not good.
No,
It's
not.
better.
Is it though?
It's,
Let's go back to the code.
just call it a feature, not a bug.
This is what the game is intended. It's a flying tank that never goes back down again.
This is now what the game is.
Yeah, you be careful when you touch the jump button.
Not jump. Yeah.
If you jump.
I've seen a game where there will be a random mode. It's like traders and you're killing each other and trying to figure out who's the bad guy, blah blah blah.
Oh, that's cool, yeah.
And there's a randomizer that happens, and one of the events that happens is like if you jump, you trip and you can't get back up. You're just laying prone. So every time someone will just not be thinking, they'll see that, they'll not be thinking, they'll just barely jump up a step and just face plant. That's what same kind of concept.
Ouch.
You gotta manage your jumps.
Yeah, ragdoll it too. That'd be fun. All right, position. Okay. You know, I messed up in the way in which I took the functions in for the raycast. So our focus is on line 65. And its methods are using exactly what we're already going to do. So what we can do is we can take vector 3 dot down, and we're going to cut it out. So we're going to cut out vector 3 dot down. We're going to remove the asterisk. There you go. Now, as the second argument in this function, so we're going to go before ground length. Now we put the vector 3 dot down in there. Yeah, there you go. And it all automatically does what we did on the DrawRay down on line 73, where we multiplied it. That's what it's doing within the raycast function. We don't have access to it. I don't know what it's doing under the hood, but I believe that's what it is. So let's hit
now there's
save.
4 parameters.
Yeah, exactly. And if we were to look at, it's called an overload, a function overload, where raycast can take in different variations of different arguments, and so it has multiple overloads for this. But let's hit play. Let's see what we get now.
Hey,
Cool.
It works really well.
That looks a lot better.
I think it's still syncing.
I think from the player's perspective, they're hardly going to notice. We can always change the terrain. What we could do is, if you're interested, we could lower ground length, but I would be careful. We don't want to make it too low. So maybe make it 1.1. We definitely don't want to go below or equal to 1.
Sure.
Because
let's try 1.1 and see what it is. Because otherwise it'll be wacky because it'll be colliding and trying to sense it and all that, right?
Yeah, it won't. Our collider is going to hit with the ground before our raycast will.
Right.
Yeah.
I think 1.1 looks better.
Okay, cool.
Seems to be working fine too.
Awesome. Well, we got ourselves a solid jump. How do you feel about it?
Pretty good.
Cool.
Yeah.
Next video, we're going to focus on turning the turret around and firing weapons.
Ooh. Cool.
Sounds good?
That's exciting.